Okay, so we're now looking at another type of differential equation. But this time, as you'll notice, we have dy dx being represented as a function of x and y. Okay, so we've got a combination. So what we need to do in terms of solving these is to rearrange. Okay, so we rearrange it so that we now have 1 over our function of y times dy dx is equal to f of x. So you'll notice here we've got some function of x multiplied by a function of y. So we divide both sides by the function of y. And that's how we get this. The next step is to integrate both sides with respect to x. Okay, similar to the last type. So we can see that what we have now is this integral of our left-hand side, 1 over g of y, dy dx, with respect to x. And we can see how our dx's will cancel. And so that we have on the left-hand side 1 over g of y dy. So we end up integrating our function of y on the left with respect to y, and the right-hand side, the function of x with respect to x. So we're going to have a look at an example. Now in our example that we have, we want to solve the differential equation for y, and that equation is x squared times dy dx plus 3y squared plus 3 equals 0. And with the other bit of information we have is that 3 is a 0 of the function. So in other words, if we were to graph it, if we were to graph the function of y, okay, that we're looking to find, then 3 would be one of the x-intercepts, okay, called a 0 or a root, okay, all meaning the same thing. Okay, so our first step is to rearrange it, okay, and what we want to do is to get it in this form here, okay. Okay, so you can see what I've worked through here is just bringing these terms over to the right hand side. Okay, so we have minus 3y squared minus 3, and then just factorising that. Just simplifying this part here with the y squared. And what we want to do now is this function of y here we're going to bring over to the left, because this is time we're going to divide both sides by y squared plus 1. At the same time, I'm going to divide both sides by x squared to bring the function of x over to the right, which is what we've got up here, see? The function of y is on the left, the function of x is over on the right. Okay, so we end up with 1 over y squared plus 1 dy dx is equal to negative 3 over x squared. The next step, of course, is to integrate. Integrating both sides with respect to x, which will result in us having 1 over y squared plus 1 dy. And on the left and on the right hand side we'll have negative 3 over x squared dx. And we can then go ahead and integrate these. Notice here hopefully that this is the arctan function, so that's going to be arctan of y. On the left and on the right hand side we'll have that integrates to 3 over x, and we'll have a constant term c, which, okay, we don't need a constant term for each one, okay, we can just represent a constant term that is for both of them just with one constant term. Now we need to solve for y. Okay, so if arctan of y equals 3 over x plus c, then, well, from this point on, we could actually consider the fact that 3 is a zero of the function. So, in other words, x will be equal to 3 when y equals 0. Okay, which means arc tan of 0 will be 3 over 3 plus c. Now we know arctan of 0, in other words, what angle is its tangent 0? Well, that is in fact 0. We just take the simplest one. So 0 equals 1 plus c, which means c equals -1. That means that arctan of y will be equal to 3 over x minus 1. Alright, and y then will be equal to tan of 3 over x minus 1. Okay, tan and arctan are inverse functions. Okay, so if arctan of y is this, that means y will be tan of our right hand side. And that's our function. Okay, no more plus c because we used our given information of x and y being 3 and 0 to find c, and therefore we have our specific function. Now before I go on and give you a list of questions that you can do, I want to show you another type of differential equation. Okay, the reason being is that the textbook doesn't have now a nice set of questions on that particular type that we just did, and so we'll have the questions out of the Watson book, and they tend to be sort of a mixture. Okay, so what we need to do now is just have a look at the next type, and we can go from there. And that type is shown here. They are of the form dy dx equals f of y over x. So it's a function of y over x. Now it's a fairly long example what we're going to be looking at, so I'm going to stop here and we'll pick it up in the next video.